Okay, so welcome to day 11 of this stream. My attempt to learn how to make a roguelike in Rust by following the roguelike tutorial and learning how entity component systems work. We've gotten so far through section 2.6. We're in the middle of that, trying to add the ability to make monsters and the player attack themselves. Currently, we can walk around the maze. We can generate a maze. We can walk around a maze. Monsters can follow us. There's still an issue where the monsters get, you can see if I walk this way, the monsters will get caught on the edge there. But whenever the monster can see us, they will shout insults at us, as you can see down here in the console. So we're going to, looks like we're extending that in the next section. See, there's the monster's chasing us. We can go around the monster, but we can't. I'm trying to attack it, but I can't attack it. So now we're going to add the ability to deal damage. The repo is over here. Local scientist / RLTK tutorial. 3 days ago was the last time I played with this. So let's take a look at this, giving monsters and the player some combat stats. You probably guessed by now that the way to add stats to entities is with another component. In components, we add combat stats. All right, so I just want to make sure we're clean here, right? Yep. All right, so vim source lib components. We're going to add another component, pub struct combat stats. Things with combat stats have a max HP. Everything is I-32 in this game, except when we have to use usize. Pub defense, I-32, and pub power. And the other thing is with this entity component system, everything has to be public. All structure members have to be public, or at least the way the tutorial is written. I imagine that once I start working on things, I'm not a fan of this. I don't think many people are, but it's convenient for the tutorial to be able to just reach in and mess around with things. But you know, maybe once we get to some real coding, we'd want to put implement some code on the struct that allows us to manipulate these indirectly. All right, so that's that, and then don't forget to register it in main. Okay, we go into main and register it right here. Combat stats. So we'll give the player 30 hit points, 2 defense, and 5 power. Okay, and I think we create the player right here. Yep, this is with player, with viewshed, and with combat stats. Max HP of 30. Oh, HP of 30. Defense of 2. And power of 5. And then monsters will get combat stats as well. And we create the monsters in a loop up here. So we'll just add that. And they're going to be a little weaker. So maybe we can win a battle or two before we get worn down. Defense of 1 and power of 4. Okay. So we've added the combat stats, but we're not using them yet. We have to first index what is where. When traveling the map as a player or a monster, it's really handy to know what's in a tile. You can combine it with the visibility system to make intelligent choices with what can be seen. You can use it to see if you're trying to walk into an enemy's space and attack them, and so on. One way to do it would be to iterate the position components and see if we hit anything. For low numbers of entities, that would be plenty fast. We'll take a different approach and make the map indexing system help us. We'll start by adding a field to the map. I guess tile content is what we're adding. So here's our map. We have tiles, rooms, width, reveal tiles, visible tiles, blocked, and now tile content, which is a vector of entities. There we go. I knew I'd get there eventually. Then, oops. I don't know why that happened. Oh, I know why. Okay, I hit F1 by accident. All right. We'll add basic initializer to the new map code. Yep. You add tile content there. You have to add tile content here. Tile content is a vec of an empty vector of new. Sorry. 80 by 50. Okay. While we're in map, there's one more function we're going to need, clear content index. For content in self-tile content, iter mute, content clear. Okay. That seems pretty straightforward. For content in self-tile content, iter mute, content clear. This seems like the kind of function you could just map the clear method over, right? Like self-tile content, iter mute, map, vec clear in other languages. There's probably a way to do it in Rust, but I don't know enough Rust to be able to do that. It iterates over every tile content list mutably and clears it. Then we'll upgrade the indexing system to index all entities by tile. All right, so we have to go into the map indexing system. And now it's a little more complex. So we have write expect map, read storage position, read storage blocks tile, and entities, tick A. Right. And then we map over system data, map position blockers, and entities. Populate blocked, and now we're also going to clear content index. For entity position, so we're no longer looking at blocks. Oh, we get it this way. Okay. So entity position and entities and positions. Right? I'm going to change this. I know variable shadowing is a thing in Rust, but why do it with this? We can just do positions. Index is map xy, position x, position y. And then if they block, update the blocking list. Okay, so let underscore p is the option of blockers get entity. If it's a sum, then set map blocked index to true. So we can simplify that a bit. Blockers get entity is sum. Right? And I know we can't put this call in here because that's like a double borrow. Somehow Rust complains if that happens. And then after we do that, we say map tile content idx push entity. So for every location on the map, we have the vector, right? That's what we just added to map. Right? We have this map. It says vec entity, but this is a vec. This outer vec is a list of all locations on the map, and the inner vec is a list of all the entities at that location. So this is pushing entity. Every entity it finds in that position is getting put on the tile content. It's cleared here, and then it gets filled in here. Okay, so we've done that. We still can't run it because we're not quite at the part where we can use it. So we have to do this first. Here's where it says if you cargo run this. Because if I cargo run what we have now, nothing is going to have changed. So this is where we're first using it. So we want to expand a try move player to consider combat stats. So here's try move player. So we'll add a reader for combat stats to the list of data stores and put in a quick enemy detector. So I'm guessing we do this. ECS read storage combat stats. And then we fetch the map. Player pause viewshed and player positions viewshed join, so that hasn't changed. The dest is still the XY index. And then for potential target and map tile content, so we're going to iterate over the vector we built and see if there's a target in there. And if there is a target, then we attempt to attack it. So where do we do the move? Oh, here. So return, so we don't move after attacking. So before we do this, we're going to put this for loop here. In map, tile, content, destination. Oh, I just call it dest. Iter. Right? We're going to say let target equals combat stats get potential target. And if it's sum t, we don't do anything with the t. So for now, I'm just going to simplify this. I'm going to regret this later, I'm sure, but I'm going to simplify this to say if combat stats get potential target, type it right, is sum. Then we'll just say console log format from hell's heart. I think it's a stab at the, I think is the quote from Moby Dick. Right? And now I'm going to try cargo running this guy. After he builds, does not build. Oh, that's interesting. We never had console in here. All right, and then if I refresh this, can I stab at my opponents? I can. Look at that. Shows it right down here. Okay, so that worked. That's good. So git status, git diff, what do we got? We added combat stats. We build a list of entities that are part of the map. We look at them when we try to move. Oh no, this builds it up. That's still the build up stuff, but we look at it when we try to move here. And if it's something, then we will print out a message saying we're stabbing. We register our component, and then monsters and players get different stats. We're not actually using max HP or HP anywhere. And I think the reason that Rust isn't complaining about it not being used is because it's part of the library instead of part of the main code, is my guess. Oh, you know what I forgot to do? Because I didn't do a return here. How come it didn't move on top of the monster? If I go right, left, 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 left. Oh, because it's still blocked. Right? It's still blocked. So even if I tried to move, it wouldn't matter. But let's add that return statement in there anyway. right here. Right? In case there's a monster type that doesn't block the player. The player can step on it or something. All right, so git add source, git commit. Player can now detect monsters and shout back at them. All right, let's push that up. So I'd like to do this for whatever reason. There we go. All right, so now player attacking and killing things. This will be fun. We're going to do this in an ECS way. So there's a bit of boilerplate, of course. In components, we add a component indicating an intent to attack. Ooh, okay, so that's an interesting concept because up to now, components have been things that we need to keep track of. I guess this is a thing we need to keep track of too, right? But it's not like, so this is combat stats. This makes sense that, a player would have combat stats or a monster would. This is a flag style component. It doesn't have anything in it, but if an entity has a component, that means that entity blocks a tile. This is another flag style component, But here's now we're adding a component that is a concept, right? A desire on the part of a particular entity wants to do something. It's not doing something. It doesn't have something. Maybe it has something in the sense that it has the desire to do something, right? Does that make sense? I think it does. But it's an interesting division between things an entity has versus things an entity wants or is trying to do, right? Nouns versus verbs kind of thing, right? Like a viewshed is something an entity has. So it's a noun on the viewshed. Renderable is something an entity has. It has some component that allows it to show on the map. Whereas this is more of a verb kind of a thing. Wants to melee. And what it wants to melee is another entity. Okay? We also want to track incoming damage. It's possible you will suffer damage from more than one source in a turn. And Specs doesn't like it at all when you try and have more than one component of the same type of an entity on an entity. There are two possible approaches here. Make the damage an entity itself and track the victim, or make the damage a vector. The latter seems the easier approach, so we'll make a suffered damage component to track the damage and implement a method to make using it easy. Okay. So in this file, this is interesting because in this file we have just the components, right, that are part of just structs that are part of the components. Now we're going to actually implement a method on a component just so that we can have a vector, right? We have a vector of amounts of damage. It'd be nice to say what the source entity was of the damage or whatever, so we can keep track of when the player dies, what was the finishing blow. That's interesting. We're going to implement something on the component. That's what I was talking about before. Everything here is pub. It would be nice if we could implement each one of these as a separate thing. Although, get the name is one thing. We don't want it to be mutable kind of thing. Okay. So what we'll do, pub struct suffer damage, mount 932, and then we're going to implement suffer damage Right, storage, suffer damage, victim, entity, amount, I32. That's it? Yep. Okay. So let's read the code here. If let sum suffering is equal to store get mute victim, then suffering amount push amount. So okay, so this is checking to see if there's already damage on the victim, the vector already exists, then push it. Otherwise, we'll create a brand new vector of damages and insert it on the victim. And then we expect that to succeed, right? All right. That's pretty straightforward. Victim, there we go. Suffering amount push. Amount, else, you create a new component and create a vector 1 long with the amount of damage, and we insert into the store. Can't type insert victim damage expect, so we just crash if we can't. Enable insert damage. Sorry, the terminology in Rust is panic. So we'll panic if we can't. You don't really want that as part of the game. Maybe we'd log something or say, oh, this victim can't be damaged anymore. Oops. Don't forget to register them in main.rs. Indeed. Source main. So we've got wants to melee and suffer damage. Why is that wrong? That's wrong because I forgot the word struct. Syntax highlighting is pretty handy. All right, so wants to melee and suffer damage. Okay. We modify the player's movement command to create a component indicating the intention to attack, attaching a wants to melee to the attacker. That makes sense. Player. So here in player, guessing this is here. In the players, we modify player's movement command to create a component indicating the intention to attack. So here's potential target, right? So this is this code here, but we're adding entities now to this. Right, and we get a list of everybody who wants to attack, right? And then where is this code? If pos x plus delta x is less than 1, pos x, right, so this is just checking to see if we can go there. And then we have this potential target. So where is this in relation to this? So this is combat, right, we're doing the combat stats, blah, blah, blah. Yeah, here's where we want to say the target. So we'll need to undo what my clever hack here is. Y Why is it doing this check here now, where that check didn't exist before? That seems like it came out of nowhere. Okay, I'm not going to worry about it for now. There should be we should be able to return from XY index whether or not. I think that would be a better way to do it, right? Source lib map. If I look at XY index, it should return some U size, or option U size. That would mean a lot of code changes around, right? Because, you know, everywhere we'd have to unwrap it, right? If we return an option U size, then we'd know here if the player was trying to move off the map. I'm going to leave this out for now. I spent more time thinking about it than it would have taken just to type the thing in, but oh well. So we'll change this back to let target equals blah, right? Change that to that, and then we'll say if target is sum, then instead of console logging, we're going to wants to melee insert, and we're going to insert the entity, which I did not get. Up here, entity, and this is entities, like that. And then a new wants to melee struct, with the target being the potential target. Expect unable, I'm going to assume it's unable to insert target, add target failed, okay. And we return, because there can only be one. Okay. Then we'll need to add a melee combat system. Okay. Let's do that. Source lib melee combat system. Brand new file. Use specs. Like that. And then I keep forgetting how I have it slightly different to the way they do it. Oh, not there. Source lib map, maybe. I use crate star. I keep forgetting that. I might be able to just say use crate like this. Combat stats wants to melee name and suffer damage. Like that. And we have our system. It has to be a struct because we need to be able to implement a trait. I could type tick A for melee combat system. Data is equal to entities. Write storage for wants to melee. That. Read storage combat stats. And write, oh, I missed one, name. And write storage for suffer damage. Like that. And our run method. Self data, self system data. Let entities wants melee name. Oops. Mute. Names combat stats and inflict damage. So we're calling suffer damage inflict damage here. That's fine. And then we loop. Entity wants melee, name and stats. In entities wants melee, names and combat stats dot join, I'm guessing. Yep. Scroll this over a little bit. All right, what do we got? If stats.hp greater than 0, let target stats is equal to combat stats get wants melee target unwrap. Okay. If target stats.hp is greater than 0, what's the name of the target? Names get wants melee target unwrap. And let damage is equal to R32 max of 0 stats power minus target stats defense. Okay, that makes sense, because if stats power is smaller than the defense, then we don't want to suffer negative damage, which would add HP, right? So we just max it out on 0, which means the smallest value, the damage will be 0. Damage is 0. I'm going to say console log format is unable to hurt name and target name. Yep, name. Else console log format hits for blah HP name target name without the comma, and then damage. Oops. There we go. Buffer damage. New damage. Inflict damage. Wants melee target and damage, I assume. Yes. And then we close all of these nested ifs, and once melee clear. Close the last two. All right, and we've got a melee target system. We have to add that to our library. Source lib mod 3yp. There we go. Melee combat system. Just like that. And then we'll need a damage system to apply the damage. We're separating it out because damage could come from any number of sources. We'll use an iterator to sum the damage. Okay? So, lib damage system. Like that, and we'll use specs prelude star. Use crate combat stats suffer damage. Pub struct damage system. And then we're going to have to add this to our game state, right? Impl tick A. Yeah, Roger, it involves a lot of typing to kill that last guy. How you doing, by the way? For damage system, type system data, right, storage, and combat stats. Yeah, it's early morning for you, isn't it? It's almost 8:30 where I am. So what I'm doing, I don't know if you saw any of my previous ones, but I'm trying to create a roguelike. I'm trying to learn how to make a roguelike in Rust using this tutorial. I've gotten this far so far. I'm up to dealing damage, and I'm learning a lot about the tutorial. Not so much about making a roguelike, but the neat thing is I'm getting a handle on how entity component systems work, which is really the underlying technology that suffer damage. That the Roguelike Toolkit, RLTK, is using. And why does this look different? This looks wrong because I'm missing the A there. So mute self, system data. So this is a system that I'm writing in the entity component system. These guys are components, combat stats, and suffer damage, and then entities get components attached to them. And this system is going to loop over any component that has both a stat and a damage associated with it and apply the damage to the stat. Mute stats damage in mute stats damage join. So we take the stats that we found, mutable, so we can change it. Damage amount iter sum I32, and it's a vector. The amount is a vector, so this is summing over all the entries in the vector, adding them all up, applying the damage all at once, which is probably not the way you want to do it if you want to keep track of who's dealing what damage to whom. And then damage.clear, which is removes all the damage from this particular play clock tick. And then we need to add a method to clean up dead entities. Okay. Is this on? Oh, it is on the damage system. Okay. So we'll make that here. Delete the dead. ECS. Get world. So we get a list of the dead. Entity vec new, and then using a scope to make the borrow checker happy. So it's probably, yeah, so we're going over the ECS here mutably, and here we're going over it immutably. So you can't have, you should be able to do that, right? If you have immutable reference, but these need to go out of scope before you can mutably borrow ECS. So that's why this is happening. It's a Rust thing. Let combat stats, ECS read storage, combat stats. I'll try compiling it without those braces, and we can see the complaint. ECS entities. And for entity stats, entity is a hard word for me to type for some reason. Combat stats join, which is going to be a problem if I'm going to be using a entity component system. Is less than 1 dead.push entity. All right, for victim in dead. ECS delete entity victim expect unable to delete, and that's delete the dead. And now in our tick command after the system's run, call that. Okay, and I think I made something called game state. Yep, and this is where tick lives. So after the system's run, right here, we'll call damage system delete the dead. And mod. We're going to have to add the damage system here to the library, so we have access to it from the tick command. Okay, and now we're going to have to run these systems, right? Does it say to add that? If you cargo run now, you can run around the map hitting things and they vanish when dead. If we add them here, though, right? We have to run these systems. Is that missing from here? Just trying to see where that it says to. It might just be missing, because I think if I run this now, those systems are not going to run. Oop! Of course, everything blows up. What did I get wrong? Oh, console's missing. Oh, I have to make this as a separate thing. That's not implementable like that. Okay. Let's fix these compilation errors first. So in melee combat system, we need to use RLTK console, right? And then in damage system, this has to be its own thing. Impl damage system. Like that. Does that look any better? There's still a problem. Player doesn't use console anymore because we took that out, and then I misspelled unwrap in melee combat system. Alright, let's fix that. Pull that out, and then grab this guy. UWW. UNW. That was the only UWW there. Does it build? Does not. Delete the dead. Not found in damage system. Really? Did I not? No, it's right here. Pub func. Source lib mod. Include star. Use star. What am I missing? Did I typo it? Source lib game. I got create star. Right? Damage system, delete the dead. Delete the dead. Yeah, those are spelled the same. Oh, I forgot to pass in the world. So like this, mute self ECS. Maybe that was it. Nope, still not the problem. Whew. It's a pub. The struct is public. The function's public. What if I explicitly add it here? Delete the dead. Like that. Will that work? Nope. There's no delete the dead in damage system. Oh, you know what? No. No. There's damage system. Damage system. What am I missing? How's the interface? Rust has something called traits, which are kind of like Java interfaces, although they're slightly different, but mostly like them in that we implement this system trait for damage system, and it's basically implementing that interface. So the interface has a system data type that you associate with it, and then a run function that you have to implement in order to implement system. But you can also add your own functions to structs by just saying implement and then the function. And I don't know what's, because if I look at, for example, what would else? So the map, right? I have pub mod map and pub use map, and if I look in source lib map, we have pub struct map, right? And then I have impl map, which implements functions on the map, and those are accessible. And it's a pub function like this. And if I look at my damage system, make sure I have the right opening and closing, I just say impl damage system. Public function delete the dead. This is confusing. And it's not like it's not building, right? Because it wouldn't compile if it couldn't see that. Like if I put a syntax error in here, right? It complained because it actually did compile that. But it's not finding delete the dead as a... This is called an artic command. After systems... Oh, do I have to... I have to create a new damage system. Oh, okay, I think I got it. So in game state, we can't just do this. We actually have to create the system and run it. And I think that's what's missing from this tutorial. Let mute damage system equals damage system like that. And then we say damage system dot run now. And then we delete the dead on it. I think you have to do that, right? Wouldn't that make more sense? Oh, maybe it's not even part of an implementation. Maybe that's why they didn't have that. All right. So light dawned earlier, but I think it was a false dawn, right? If we do this, put the double colon in there. I think we still have to do this and the melee combat system as well that we added. But I think what happens is this comes out like this. Let's unindent all, oops, and get rid of that too. There we go. Like that, and then get rid of that line. Okay. That should compile. Yes, okay. But now we have the melee combat system that we have to run as well. Source lib game state. So let mute melee combat system is melee combat system dot run now self ECS. All right. Let's see if that works. Good. Okay. And now the question is, so what actually changed here is that we can now attack monsters and we should be able to kill them, right? So let's refresh this and see if we can kill a monster. I don't think it's working. I'm attacking the monster, but nothing's happening. So what did we fail to do here? We're not, the damage system isn't working, or maybe it's not even getting called. We should see if the melee combat system is actually combating. Let's use our tried and true method of debugging by printing, right? So let's see if we can at least suffer damage. Let's go to the suffer damage thing. source lib mod. No, it's in components. All right. Add a console here. Actually, you know what? I'll just add it here because that way I can remember to remove it. RLTK console, console log, format, attacked for amount. Like that. What did I do? Oh, it's colon log, right? Like that. Okay. Now, do we see that show up on the monster right over here? No, so it's not getting called. All right, so I missed a link between suffering damage right. So this is wants to melee. Let's see if we're hitting that. It's the player, right? Console. Use RLTK console colon log format. Attacking target. Like that. And what happens now? We go find a target. It says attacking target. Okay, so we got that far. So we're inserting into the wants to melee here. This is happening. And then after that, we should be running our melee combat system and finding this here. So we were looking here to see, we should just print out that we're running the combat system here. Our console log format in melee combat system. Build that. That failed because I forgot the exclamation point and the second parenthesis. There we go. Okay, so we're not getting to the melee combat system. So that's where the disconnect is we're not finding anything here. And I wasn't seeing any of the. So this is wants to melee insert, right? Then after that, we run this, which inserts the suffer damage. So if stats.hp is greater than 0, I can print that. Oh, we're not even getting in there, right? We're not seeing this in MCS. I didn't want to put it here because I think this gets run every tick. But we'll see. Oh, it gets run. Oh, there it is. Okay, so it's going in there. So it's not every tick, it's every move. So it's not finding anything that is an entity that wants to melee with a name and combat stats. And I know the player has combat stats, and I know the monster has combat stats. I know the player has a name. We can just double check that. Oh, the player does not have a name? Okay, is that the bug? With name player. Do I have to do toString? I don't know if I have to do toString. Let me look. We just do format, blah, blah, blah. Yeah, so we'd have to do toString. I wonder if, is that the bug? Really? Did we just miss that when I was adding names to things? Yeah, look at that. Player hits orc 8 for 4 hit points. Wow. Okay, so that was the bug. Interesting bug. All right, let's get rid of the console logs. Not a monster AI system, melee system, right? We don't need this. And was there some other place I added? Yeah. The running into monster stage isn't doing anything other than stopping you. Yeah. That's the thing is there's a component. I don't know if you've watched the other ones, but there's a component called blocked, which any entity that has blocks tile on the component as a component on itself means the player can't move into it. So interestingly, the walls are not set up that way. The walls are separate. So the map is separate to all of the other things, which will be interesting when we get to the point where we want to actually modify walls like stone to mud spells and things like that. Where was I? Oh, I was going to do a git diff to see what other console messages I need to remove. I normally put like a XYZZY string in any console log messages I want to write. So it's easy to grep for, but I didn't do it this time for unknown reasons. Git diff stage. I'm going to look at everything now. So we added a wants to melee component and a suffer damage component. The suffer damage component allows us to add damage amounts to a player. And we have a damage system which gets run and it sums up all the damage that a player suffers, or an entity suffers, and subtracts it from their HP. And then we have this function called delete the dead, which apparently has to live in global namespace. Because it just takes the world, so it really should be like a method on the world. And then we call it here when we want to delete any entity that has died. Any entity with less than 1 hit point is dead. We run the two systems we've created. And this is the other system we created. We loop over everything that is an entity, wants to melee, has a name, and has stats. And that name, can't believe I overlooked that when we did the names originally. All right, so there's the library. We added the melee combat system and damage system to. This is the player. The player now has the ability to want to melee with a monster. And we can insert that desire into the entity. And then we registered our systems and, of course, added that name, fixing that final bug. Okay, so I think we're good at this point. Git commit player can now attack monster. Oh, you know what we didn't test to see is if can we kill the monster. Ooh, look at that. Monster died. How about that? So we're able to kill monsters, but the monsters can't hit us back. Which is kind of unfair, but you know, it's an easy way to win the game. Okay. Player can now attack monsters. Actually, you know what I didn't do was do my cargo format and cargo Clippy. Clippy's happy. Format reformatted things for us, of course. Wow. Formatted a bunch of things for us. All right. Yeah, it spread these guys out. All right, so we'll just add that. Git add source, git commit -m cargo format, and we can push that. Like that. And because I like to take a look at the commits over here, there they are. Let's just take a quick look at this guy. Yeah, cargo format likes the colon next to the variable name. This got spread out. That's okay. This all looks good. All right, this is a longer stream than I normally do. I normally do half-hour streams, but I couldn't stop until I could kill a monster, which is the way it should be. All right, with that, I think I'm going to call it a stream. Thanks very much for watching, and I'll see you next time. Take care.